Hi everyone, and welcome back to chemistry. This is Mrs. Hutchinson, and we're going to continue with scientific measurements, but now we're really going to focus more on reference table C and the metric conversions that we can obtain from that reference table. So, if you do not have your chemistry reference tables out, please get them out and turn to reference table C. You can pause the video while you are doing this to make sure that you do not fall behind. So our international units of measurement happen to be the metric system, or they're known as SI units because, well, in French, system comes before international. Now, the fundamental metric units that we use are typically one-dimensional units. So length, we use the meters, mass, we use kilograms, times in seconds, temperatures, typically in Kelvin, but often degrees Celsius is used because it's just easier. And then amount of a substance, which we will learn later on, happens to be a mole. And you can obtain all of these values over here, and by values I mean all of these units. You can obtain all of that information from reference table D. So if we take a look on reference table D, we've got our length is measured in meters, mass is typically in grams or kilograms, temperature is in Kelvin, amount of a substance is in mole, and take a look at all these time units that we have. We also have joules for energy and work, concentration parts per million, volumes liters, solution concentration is molarity, and atomic mass is the atomic mass unit. So you can get all of these units found right on reference table D. It's basically all it's really good for. If you just kind of get tripped up on, well, what is the unit actually telling me? So we also have something known as a derived unit. So a derived unit differs from a fundamental unit because a derived unit actually is something that we have to calculate. So volume, length times width times height, that is a derived unit, because we actually calculate it. So if we had meters times meters times meters, we would get meters cubed. Typically, if we're talking about a liquid volume, though, instead of meters cubed, we're going to talk about liters, and often milliliters are used. Density, as we will learn, or probably already have learned, density equals mass over volume. The units for mass are grams. Volume, like we said, can either be in meters cubed, well, it could be centimeters cubed, or it could be in milliliters. So because we had to calculate that unit, it is known as a derived unit. So how to take a look at reference table C. Many of you probably learned the killer round dog moving the decimal over shenanigans, but really the metric conversions, they're pretty simple, because they're all just factors of 10, which is really nice, as opposed to our 1 foot equals 12 inches, and then 1 yard equals Lord knows what. Okay, it's a lot easier when we're dealing with factors of 10. Reference table C gives you 3 things. It gives you the factor that we're going to be multiplying or dividing by, gives you the prefix, and then the symbol for that prefix. So let's take a look at how to use this. So on reference table C, for the factor, what you want to place after the factor to make our conversion factor that we can use to go from a base unit or a fundamental unit to a unit that now has a prefix. So you want to put something known as your base unit after the factor itself. So the base unit that we're talking about, that could be something like grams or liters or meters. Okay. And over here, behind our abbreviation, we're going to also place our base unit, which could again be our grams, our liters, our meters, our seconds, any of that stuff. So how do we use this to actually make a conversion factor? Well, we can say that 10, let's just say meters, as our base unit. It's a pretty easy one. So if we're dealing with how to convert between meters and picometers, so we would say that 10 to the negative 12th meters is equal to 1 picometer. Okay. So you will always place a 1 in front of the value or symbol with our prefix in it. Okay. That's how you're going to use this. And basically what that's saying, if we take a look at, say, kilo, everybody knows kilograms and things like that. Kilograms, as we know, are larger than grams. So, again, 10 to the third grams is equal to 1 kilogram. So if we just write that out as a conversion factor, we would say 10 to the third grams equals 1 kilogram. And this turns out to be an equivalency statement that we can then use to convert from grams to kilograms, or vice versa, from kilograms to grams. Okay. So, we have a worksheet on this. We're going to practice making conversion factors using the reference table. So, again, here's how you want to do this. You want to put the base unit after the factor. We'll then have an equal sign, place a 1 in front of our symbol, and put our base unit after the symbol. And they're always going to be equal to one another. So again, the example for grams to kilograms, if we rewrite this, is 10 to the third grams equals 1 kilogram, which is 1,000 grams is equal to 1 kilogram. Okay, so go ahead and try this worksheet, and I will see you at our next video.